Alright, so this video we're going to be focusing on different damaging types. So I already have some prefabs of some of the towers that we'll be working with. So we got the basic tower, of course, the OG, and then we got the flamethrower, the flamethrowing tower, spit bars, and you got the laser tower, and you have the missile launcher. So yeah, these are the four different damaging types that we're going to be working with. So the basic and laser will kind of share the same thing, but one will have a special attribute. Missile launcher, projectile, and the flamethrower is going to be using the particle systems. And also all the meshes will be in the description for you to download. And the way that I applied them onto the tower is that I just copied the basic tower and I went to the tower head and I just changed its mesh to the tower head that I want to work with. Yo, new tower, guys. It's a table. But yeah, these are the four different tower types that we'll be working with. So I can get rid of these in the scene. Don't need them now, at least. And if we go to the 2D view, here you could see that I set up all of my placement buttons. And the way I did it, I just duplicated the place basic button over, just change the text, and change the prefab that it is pointed to whenever we are placing stuff. So yeah, set this up real quick before we get any further. What the?
The virus I implanted has worked. This should buy me some time to start generating my army of cubes undetected. Ritex fall will be quite the spectacle.
Alright, so back in the Unity scene, once you have all of your tower buttons all set up, you can go to your classes folder, go to towers, and we're going to start by creating the standard damage. And once you created a standard damage class, you can just open it into Visual Studio and we can get coding. Alright, so now in Visual Studio. So before we get into anything, I want to go over a little error that I had in the last video, and that was back in the tower targeting class. And it is the part where we set the enemy index to return. And the problem here is because our enemy to index can default at -1, we have to check if it is -1 before we actually do this, as it will throw an error and cause none of the native collections to be disposed, causing memory leaks and some bad stuff we don't want to deal with. So to fix this, we just do an if statement, enemy to index 0 does not equal to -1. Then we will run this, and we can take this and put it in here, and we can put the return null on the outside. And since we have the return statement inside of this if statement, then what we have to do is dispose of our native collections after we set our enemy index to return. So once that is all set up, the tower targeting is now good. Now the next thing we need to set up is in our game loop manager, when we're going to now implement damaging enemies into the game loop. So in the game loop manager, we're going to create a public static variable, and it's going to be a public static queue, and it will contain a type called enemy damage data. And we can call this enemy damage datas. No, I'll just call it enemy or damage data. Damage data. There you go. And the enemy damage data is going to be a struct that we will create underneath our class here. So public struct enemy damage data, or public struct, not static struct. There. And what's going to be inside of the struct is going to contain a public enemy class, and this will be the targeted enemy. And it's going to also contain a public float of total damage and a public float of resistance. So the resistance is basically just the total damage, what the total damage will be divided by, basically. And once we have these three variables, we can now create a constructor for our struct here. So public enemy damage data, pass in the three parameters we want to populate, so enemy target, float damage, and float resistance. And we can just set these variables up. Alright, so now this is all set up completely. And if we go back up, yeah, the error should be gone now. And also in our start method, we're going to want to initialize this queue, so new queue of enemy damage data. And in our game loop, we're now going to implement this. So it's basically like the same code as our remove and summoning code in our loop, but this time there's going to be a little bit of like a little more extra workaround. So enemies to remove, it's now going to be enemy damage data or damage data. Yeah, damage data. Damage data count is greater than 0. Then we're going to go through the entire count, but instead of doing dot remove enemy, we're going to get a reference or create a little reference variable inside here. So it's going to be enemy damage data. Call this the let's call this current damage data, and this will be the damage data dot dq. And after we dq the damage data, we're going to get the targeted enemy and subtract the health by the damage data dot the total damage divided by the current damage data dot resistance. And there you go. And once that is all set, what we can do is check if the health is less than 0 or less than or equal to 0, and we will put it inside of the enemy to remove queue. So we could take our function here and queue enemy to remove and put in the current damage data dot targeted enemy. And there you go. And we can also create a public static void for this queue here, our damage data queue. So we can do enqueue damage data, and it'll take in an enemy damage data parameter. Call this damage data, and we can just do damage data dot enqueue the damage data. And since we have these 3 public static voids, we don't really need to make the queues up here public static, so I'm gonna make this private static queue actually and just move this down. Oh, and whoops, the damage is supposed to be underneath the damage, so swap that underneath damage and put the remove code underneath the remove. And there you go. Now the loop is all set up, and it is now incorporating the damaging of enemies. Now we can go back to our standard damage class, and in here, since this is the OG damage class, this is the first damage class, we're gonna make this the class that will contain the interface for our damage classes. And this interface is gonna be called iDamageMethod. And a quick rundown of interfaces, they're basically just contracts for different classes. Basically, each class has to meet a required function that is inside of the interface. There will be a card on the top right of this video for you to actually see a video that I made in interfaces. It goes way more in depth than how I'm saying it right now. And yeah, so public interface iDamageMethod, and this will take in a public void of damage tick, and this function will take in a reference to an enemy of target, and it will have another function called init, short for initialize. It'll take in a float for damage and a float for fire rate. And once we are done with our interface, we can make our standard damage class inherit from it, and we don't need the start and update method, so we can just get rid of those, and we can just implement these 2 interfaces. And once our 2 interfaces are implemented, I can take this initialize function, put it above the damage tick, and now what we're going to do is create 2 private floats. One private float will be the damage, and another private float will be for the fire rate. So the init is just going to copy these variables over to itself internally, so we don't have to constantly pass in parameters to our damage tick function. So this.damage equals damage, this.fire rate equals the fire rate. And of course we need to create our private float of delay, so basically the time between operations. So delay equals 1 divided by the fire rate. And there you go, that is the initialization function. now in our damage tick function, since this is the standard damaging type, we're just going to wait for the delay and then apply the damage that we have to our given target. So we'll just do if delay is greater than 0, and we'll do delay minus equals time dot delta time, and we'll return out of the function. And since we return out of this function, if it is greater than 0, then it will make everything underneath basically run if the delay is less than or equal to 0. So at the very end of the bottom here, we can just set the delay back to 1 divided by the fire rate, and everything on top, we will just apply damage to the target. So we'll do game loop manager dot enqueue damage data, and we'll pass in a new damage data, and inside we're going to pass in our target, we're going to pass in our damage parameter, and for the resistance, that will be on the enemy itself. So we got to go to the enemy for that. And in the enemy class, we can just create a public float of damage resistance, and we can default this to 1. And now back in our standard damage class, we can now just take our target and do dot damage resistance. And there you go. And that is basically the damage tick for our standard damage. And the damage tick function is going to run every time the tower ticks regardless. So since that is the way it will be implemented, we're now going to go to our tower behavior class now. And what we're going to do is we're going to need to get a reference to our damage class, or our like specific damage type class that we have attached. And to do that, since we have an interface attached onto our different damage classes, instead of doing a try get component for each type, we can just get component for that interface. So what we could do underneath all of our parameters, we can create a private reference to our iDamage method and call this current damage method class. And what we could do is current damage method class equals get component iDamage method. And if there is no current damage method class, so current damage method class is equal to null, then what we could do is just be like, hey, this ain't supposed to happen. We need a damage class, so we can just do towers and then just say no damage class attached to given tower. And there you go. So once it's initialized, we can now just go into our tick function here and just do current damage method class dot damage tick and pass in our target. And also in our start method, after this little check for whether or not the class is null, we'll do current damage method class dot init, and we'll pass in our damage and fire rate. So there you go. And we could also put this in the else statement, so it doesn't run after we say the error. And then it'll just be running on empty variables, so it doesn't even work regardless. So yeah, there you go. That is, I believe, all we really need to do to set up our standard damaging class. And this damaging class is going to be attached to the basic tower. Oh wait, no, there's one more thing we need to do. I almost forgot. So back in our standard damage class, we need to check if the target exists, so we don't run into any weird errors. Just like that. So we gotta check if our target exists before we do any sort of operation. Yeah, we can just keep it like that, and now it should be complete. So now if we go back into Unity, and we take out a basic tower, and we attach a standard damage, and we apply the changes, go to our prefab, and inside we just move the standard damage up, make it look nice, clean, and organized. It should now be ready to do some damage to some cubes. So yeah, we can get them out of the scene and hit play. If we place down a couple towers, there you go. You could see that enemies are now being destroyed by the towers. They are now functional. Alright, so enough of that madness. Now it's time to work on laser damage. So I'm going to go to our prefabs, towers, take out our laser prefab. And right off the bat, we need to make a point for us to add in a line renderer to give us a good visual of an actual laser. So Underneath the head pivot, we're going to create an empty game object, and we can call this laser pivot. Laser pivot, there. And we could just go into isometric view and kind of line this up with the tip of our laser tower. So kind of move this over here. Like around at that point, that looks good. Yeah, that's a good point. Alright, so now what we're going to do is we're going to add in a line render effect, and we're also going to turn on use world space. And now what we're going to do is move the positions up a bit so we can actually see what it looks like. So just like that. And we're going to set the color to go from a gradient of green over to a gradient of red to show that it's dead. This laser is dead. And now what we're going to do is change the width of the laser to make it to where it looks like it's expanding. So this looks nice. Yeah, this looks nice. And now that that is set up, we can now just disable the line render. And now we can apply the prefab changes. And now we can get coding for our laser damage. So we're going to go to classes, towers, and we're going to create a new C# class and just call it laser damage. Once that is all set up, we can now just attach this to our laser tower here, apply the changes, and we can get coding. Okay, so the laser damage class is generally the same as the standard damage, but we're just implementing in the line renderer, and we're making it ignore armor. We can implement our interface here and get rid of our start and update method. And to save some time, you can go to your standard damage class and copy over this code. This is kind of the general damaging code here, so we can copy this into the damage tick function. Move the tick underneath the inits, and we can copy this code. Just copy the code over to the laser damage from the standard damage. So just copy all this over. There. And now we're going to add on is the line renderer. So I'm going to create two serialized fields. The first one will be a transform, and this is a reference to the laser pivot. And the second one is going to be a reference to the line renderer itself. And we can call this laser renderer. Now what we're going to do is in the part where it says if a target exists and it comes in as true, we're going to set the laser renderer to enable to true. And we're going to set the two positions of the laser renderer to the laser pivot and to the enemy's root object. And when I say root, I'm just referring to the center of the enemy, so it actually looks like the laser is hitting something. So let's go to our enemy class, and what we're going to do is just create a public transform, and this will just be a reference to our root part. And now we can go back to our laser damage class, and we can now set the positions of our laser renderer. So the first position, set position, 0s for the first position. We're going to set that to our laser pivot position. And we're going to set the second position to the target.rootPart.position. There. And if the target does not exist, so we can put a return after all of this code runs. So therefore making all the code underneath a case where the target does not exist. So if the target doesn't exist, then we set enable to false, our laser renderer. So it shows that the laser is no longer just shooting at nothing. Also, in the entity summoner class, as a little failsafe, just in case something goes wrong whenever we're summoning any enemies or killing them, since it happens at a really fast pace, it's normal that maybe one of the lists, I have it be the enemies in game list or enemies in game transform list, kind of has a duplicate. So to prevent that, we can just do simple if check on each of these lists. So a way we can keep the if statements on one line is doing if enemies in game dot contains summoned enemy, and we just put an exclamation point. We don't have to put in our curly brackets here. We can just put it on the same line, and we could do the same for our enemies in game transform. And there you go. This will now prevent any duplicates from happening in our two lists that contain all the necessary things from our enemies for them to be functional. So now if we go back into Unity, and we assign the parameters on our laser damage script, so we put our laser pivot on the laser pivot slot, and our line renderer here to the laser renderer. And now before we start, we now have to assign the root on our enemy, since that's a new parameter that we created. So underneath our prefabs folder, entities, enemies, go to our basic enemy, open the prefab, and assign our cube to the root part, since this is generally the center of our enemy here. And we get out of the prefab. Oh, and we also have to set up the parameters for a laser tower. So the best parameters that work for me when I'm working with these types of towers is a fire rate of 25 and a damage output of 0.2. And that will be fairly balanced for a level 1 laser tower. So yeah, apply the changes and then we can get rid of it in our scene. And then we can hit play. Now if we place down our laser tower here, you can see it doing work on these basic enemies. Alright, and that is it for this video. I don't want to make this video too long, so I'm going to separate the missile launcher and the flamethrower in the next episode of the series. So, if you enjoyed this video, like, subscribe, yeah, and I'll see you in the next video. Goodbye.